Okay, I want to know how many terms there are in the sequence that's being described. How can we go about figuring this out? Yes. This right here means the sum. We have two formulas for the sum. They both result in the same final answer, but we're going to need to decide which one makes the most sense for us to use here. We have this one, or we have this summation formula. Which one makes the most sense to use with what we've got? First one, because we don't know what the nth term is. We know what it all adds up to, but we don't know how many terms we're finding or how many terms we're using for this summation. So we're going to use this one right here. In the place of s sub n, we can replace that with a 21. Don't know how many terms, so I have to leave that as n over 2. Can I make a substitution in the place of a sub 1? Yes, I can put negative 2 in there. Plus, can I do a substitution there, or do I have to leave that as n minus 1? I have to leave it as n minus 1. And can we do a substitution in the place of d? 1/4. All right, where can I go from here? Yep, we can distribute this 1/4, and I can multiply the 2 and the negative 2 together. So that would give me negative 4 plus 1/4 n minus 1/4. This is still an n over 2 here, and a 21. Are you guys okay if we go ahead and get rid of the denominator of 2 so that we don't have to deal with a fraction on the outside of those parentheses or those brackets? How would I get rid of that denominator of 2? Multiply by 2. So I'm going to multiply here by 2 and here. So I've got 42 equals, and I'm going to go ahead and combine my like terms here at the same time. So I would have 1/4 n minus 17 over 4. Because negative 4 is the same as negative 16 over 4, and I'm going to combine that with a negative 1/4. Oh, I forgot the n on the outside. Thank you. I felt like I was forgetting something. Yes, ma'am.
Is the quiz tomorrow calculated?
Yes. Thank you, Carrington. There we go. Now I would distribute that n. So I would have 42 equals 1/4 n squared minus 17 over 4 n. What do you think we should do from here? You can get 42 to the other side. If we're going to factor, are you guys okay if we get rid of that denominator? How can we get rid of the denominator here? Multiply everything by 4. So I'm going to multiply 42 by 4, and I'm going to multiply this side by 4 so that when we go to factor, we don't have to deal with those fractions. What is 42 times 4? $168. So I have 168 equals n squared minus 17n. So 0 equals n squared minus 17n minus 168. Gonna need to factor this. Two numbers that multiply to negative 168, but add to negative 17.
So 7 and 24,
7 and negative 24. All right, so in its factored form, I have 0 equals x plus 7, no, sorry, not x, n. N plus 7 times n minus 24. So what are my values for n? Yep, n equals negative 7, n equals 24. Do both of those make sense based on what we were looking for? No. What does make sense? 24. We can't have a negative number of terms that we are adding up. So there are 24 terms in this sum. All right. So far, so good? There is one last thing that we need to cover as part of 10.2. It's part of the homework, therefore you can expect it to most likely be part of the quiz. This last thing that we need to talk about is inserting arithmetic means. So the definition of an arithmetic mean is if I have two numbers, we'll call them A and B, C is the arithmetic mean if I put it between A and B, and that sequence makes an arithmetic sequence.
So it's just like E divided by 2? Like, if it's like 1, wait, if it's like 2 and 4, then it would be...
Yes, that's exactly right. We'll do this with a couple practice problems. You guys okay if I put the first practice problem up? Okay. So we are going to insert 3 arithmetic means in between 3 and negative 5. So 3 is our first term. That's A sub 1. This is going to be the last term, A sub n. And in between those two, we're going to have 3 other numbers. So if I saw this sequence written out, it would start with 3, and then there's some number here. I'm going to call it C1, C2, and C3. and then negative 5. And this is going to make an arithmetic sequence. And we're trying to find what those three numbers are. So I called negative 5 a sub n, but when I write it out like this, can you tell me how far in the line negative 5 is? It's the how manyth term? Last. How far in the line, though? It's the 5th term. So instead of calling it a sub n, I'm going to call it a sub 5 so that we actually see its place right there. What am I going to need to know if I'm going to find these three numbers? Yes, I need to find the common difference. How can I find the common difference with the information that I've got? So I'm going to use a sub n equals a sub k plus n minus k times d. And you're absolutely right, Carrington. We're going to do exactly what you said. I'm going to put negative 5 in the place of a sub n. I'm going to put 3 in the place of a sub k plus n is how far in line a sub n was. Negative 5 is the how manyth in line? 5th one in line. Minus how far in line is 3? That's the first term. Times our common difference, which we don't know. So I've got negative 5 equals 3 plus 4 times the common difference. Subtract 3 from both sides. Negative 8 is equal to 4 times the common difference. So what is the common difference here? Negative 2. So C1, the first number that we're looking for, I would take the first term in the sequence, 3, and I'm going to subtract 2 from it. What is that first number that we're looking for then? 1. To find the second number that we're looking for, I'm going to take the one that came right before it, and then we're going to subtract 2 from that. So what is our second number that we're trying to find? Negative 1. To find the third number in the sequence, I'm going to take negative 1, and I'm going to subtract 2 from it. Negative 3. So here's the three numbers that we were looking to find, so that our sequence, when all put together, would look like this. 3, and then 1, negative 1, negative 3, negative 5. There's our sequence. Let's try another one like that. We're going to insert 3 arithmetic means between 2 and 9. So how many total terms are we considering here? 5. The 3 that we're going to add, and then they're giving us the first and the last. We're going to insert 3 terms. And then we also have this one and this one. So 5 terms total. What are we going to need to find? Common difference. So I'm going to use that rule for the nth term. A sub n is equal to a sub k plus n minus k times d. Tell me what to substitute in. 9 for a sub n, 2 for a sub k, plus
5 minus 1.
Yep, 5 minus 1, because we've got the 5th one in line, 5 total terms. We have the 5th one. We have the 1st one. Times our common difference. So 9 equals 2 plus 4d. 7 equals 4d. So what is our common difference? 7/4. So we're needing to find 3 terms here. We're going to call them C1, C2, and C3 again. So to find C1, what do I need to do? Add 7/4 to 2. So 2 plus 7/4. That means I'm going to need to rewrite that 2. How do I rewrite 2 with a denominator of 4? 8/4. So 8/4 plus 7/4 gives me what? 15/4. There's the first term we were looking for. It's the second term in our sequence, but that's the first one that we were asked to find. So there's one of them. To find the second one, I'm going to take 15/4, and I'm going to add 7/4 to it. 22/4. Can we reduce that at all? What would that reduce down to? Yep, 11/2. And then we still need to find the third one that we were asked to locate. I'm going to use the unreduced version so that we can already start with our common denominator. So what is the 4th term in this sequence, the last one that we were asked to find? 29/4. So if I were to see this sequence all written out, it's going to start with 2, and then it's 15/4, and then 11/2, and then 29/4, and then 9. I have one final example for us, and then I'm done for today. That finishes out 10.2. I want you guys to find the common difference on this, but we're going to discuss at the beginning how many terms we are going to have in this described sequence. Instead of inserting 3 arithmetic means, which is what we've done on the last 2 problems, this time we're going to insert how many? Insert 6 arithmetic means. So how many terms total are we considering here? 8 total terms. I want you guys to find the common difference And then we'll stop and compare notes before you find what those 6 terms are. What is the common difference? Negative 108 over 7 is correct. 56 is the 8th one in line, so this would be a sub 8. So we would have a sub 8 is equal to a sub 1 plus 8 minus 1 times the common difference. Here's where that 7 is coming from. So I have negative 56 equals 52 plus 7 times the common difference. So negative 108 equals 7D. Common difference is negative 108 over 7. And then from there, we just need to use the recursive definition to find the first term that we were asked to find. We're going to take a sub 1, 52, and we are going to add negative 108 over 7. I need to write 52 with a common denominator. What is 52 times 7? 364. So 364 over 7 minus 108 over 7, which would give us what? 256 over 7. So So there's the second term in the sequence. To find the third term, we do 256 over 7 minus 108 over 7. So what is the next term? Should be 148 over 7. The third term we were asked to find, which is the fourth one in the sequence, is how much? 40 over 7. Fifth one in the sequence, the fourth one that we were asked to find, 40 over 7 minus 108 over 7. Negative 68 over 7. Two more. Negative 176 over 7. And negative 284 over 7. Yes. How could we check to make sure that that was actually correct? What one additional step could we take? Yes, subtract 108 over 7 one last time, and it should all reduce down to what? Negative 56. Nice work. Very nice work. I don't have anything else for us today. You guys have the remainder of the class time, which is about 15 minutes. You can work on your homework. You can ask me questions. Things that I would make sure to know for tomorrow. Obviously, all the stuff that we've done with the arithmetic sequences in series. So, know the formulas for summation. Know how to insert arithmetic means. Know how to find terms and how to write the rule for the nth term. And then the stuff that we talked about in 10.1, if I give you a rule for the nth term, can you find terms in that defined sequence? If I give you a rule and summation notation, can you tell me how many terms we're adding together? Can you find those terms and then actually calculate the sum there? Those are kind of the big ideas that we talked about. We also talked on Friday about how to write things using summation notation. So if I describe a sequence to you, can you find how many terms we're adding up? Can you write it with summation notation, and can you find the sum? All right. Looking over the 10.1 and 10.2 homework and the types of questions that I was asking there, and the formulas that you needed to use, those would be the things that I would study for tonight. 10.2 homework is due tonight.